Starting key area 2 in the water cycle topic, and what we're going to kick off with today is drought. So what drought is, the fact that there's different types of drought, and we're going to be able to have a bit of an idea kind of what characteristics and what things we're likely to see in different stages of drought. And then we're going to look at the physical causes of drought. So one physical cause of drought is something called ENSO, which stands for El Nino Southern Oscillation, and that includes El Nino years and La Nina years, and we're going to be able to kind of sequence El Nino through and La Nina years through, understand what it is and how it increases both risk of drought and risk of floods for different parts of the world. Okie dokie then, so we're only probably going to get through today 5.4a. Alright, what drought is, the causes of drought, and have an understanding of ENSO. Yeah. Right then, geographers, so what is drought? Well, the United Nations define it as an extended period of time that could be a season, a year, several years, or even decades, where we get a lack of rainfall compared to the average for that region. Alright? Drought is a hazard, and it's one of the top 6 biggest killers out of all natural hazards. And one of the reasons for it is geographers have described it as a slow onset or a creeping hazard. It means that it takes its grip and the impacts kind of are gradual rather than immediate, and that's probably one of the reasons why it's not as media or newsworthy as a hazard such as a tsunami, a hurricane, a flood, because you can't really put your finger on that's happened today, like you can with a tsunami, and you can see the impacts and they're obvious. With drought, it creeps up on people and communities and countries, so we could describe it as a slow onset or a creeping hazard. And I've just one brilliant little case study example to highlight that is a region in North Africa called the Sahel, and if you want to check how it's spelt, that's just there on the map. And if we just have a look at a rainfall graph for the Sahel, you can see that prior to 1970, in this section, the multi-year average for the Sahel in terms of rainfall was a positive one. Yeah, so that is what the average or the mean rainfall is up to 1970. But then 1970 onwards, that multi-year average, it's kind of the patterns change quite significantly. So from 1970 to 2000, there's lots of years where we've got deficient rainfall. All right, would say it's unreliable. It's not as plentiful. There's basically not as much rainfall. And I suppose one challenge for scientists and geographers is to think, well, this has been now happening for 1970 to 2018, 48 years. Is this the new average, or will we see a day when possibly rainfall levels go back to what they were prior to 1970? And that's probably one of the challenges. Now, if you think about the latitude of this region, then if I draw on the equator, this would be equatorial latitudes where convectional rainfall is high. We've got rainforests in countries like Congo and the Cameroon, very humid, very warm and wet. And then the other extreme, as we travel north, we've got the Sahara Desert, which is find deserts at roughly 35 degrees north of the equator. All right, and as we go north, I think it's fair to say the level of rainfall gradually decreases. Now, the Sahel, which is all these countries like Mauritania, Mali, Niger, even Burkina Faso, Chad, Sudan, Ethiopia, they did rely on kind of monsoonal rains as well. But what we're finding is increasingly year on year, those rains are becoming less reliable and less intense as well. Yeah. It would be wrong to say that the Sahel is desert. All right. It was once, or some parts of it are, it's still kind of productive land, so you can still graze cattle, grow some basic crops. Yeah. Right then, folks. Now, there are different types of drought. All right, and there's 3 or 4 that we need to kind of recognise. The first type is meteorological drought. Now, meteorology is the study of the weather, so this type of drought basically means there's a significant deviation from the long-term mean precipitation. So, we're expecting a certain level of rainfall, which has been the average, and it's much lower than that. So, a lack of rainfall, causes drought. The second type is it progresses on from meteorological drought onto soil moisture drought and hydrological drought. So it's kind of when that lack of rainfall witnessed in a meteorological drought starts having kind of impacts, I guess, on the environment. So hydrological drought is when there's a major deficit in supply and availability of surface and groundwater. In layman's terms, it just means rivers are drying up, reservoirs are drying up, stream flows reduced, etc. Soil moisture drought is when the soil becomes obviously very dry, baked, and outputs from the soil are far greater than inputs. So I've got a couple of photographs just to show you. Alright, so soil moisture drought, evidence of that. Definitely in this photograph. Crops have dried up, soil is bare. Doesn't take a rocket scientist to figure out what soil moisture drought looks like. Hydrological drought. I've got another photograph of Lady Bower Reservoir, I think in 1959. Severe drought in that part of the world. You can see reservoirs completely dried up, stream flows reduced, etc. Alright then. And we're going to look at this progression of drought in a little bit more detail. So you might want to make some notes on this. Let me get rid of that. Right. Right then. So here we have a more detailed kind of overview of the different stages of drought. I don't need you to copy this word for word, but create some kind of flow diagram with some details of the characteristics, alright, but simplify it a little bit. So if we start at the top and work our way down, then we have got some natural variations in climate. So some years we'll get a little bit less rainfall than others, some seasons will get a little bit less rainfall than others. That's quite normal, so that's kind of natural fluctuations in the climate. So that stage isn't drought yet, alright. If we reach, we'll just look at this section just here, and we'll look at meteorological drought and what it looks like. Well, we know that meteorological drought is when there's a lack of rain that's outside the kind of mean average, and what things are we likely to see? Well, a lack of rainfall in terms of the amount that we receive over that season or that year, its intensity as well, if it does come, such as like the monsoon rains, are not going to be as intense as normal, and timing as well can be kind of unreliable. The Sahel particularly is an example where monsoon rains aren't as intense, they're not as regular and as predictable as previously, and there's not as much. Also, air temperature and winds might be affected, so we've got less humidity. We might have warmer temperatures, which means evaporation rates are higher out of the. So we've got more outputs than inputs within drainage basins as well. That then affects your processes, which we're all familiar with, such as there's going to be less infiltration, less runoff, less groundwater recharge, and more evaporation. Alright, so that's kind of like stage 1. Yep. Stage 2, or the second type of drought, is when it severely starts affecting the soil moisture, and that we'd term as agricultural drought. So that's the first one. Second one is when soil moisture is severely affected. So these processes have kind of intensified and it's lasting longer. Yep. So your soil moisture levels are really suffering, just like in the previous photograph, and that's having an effect on agriculture, on crop growth, natural ecosystems and natural plants. They only specially adapted plants might stand a chance of surviving. The rest are going to die. So basically, plants die, crops die, because there's a lack of soil moisture. If this continues even further, then we've got hydrological drought, which means your stream flow reduces, your reservoirs dry up, like we've seen in the previous picture, lakes dry up, ponds dry up, wetlands dry up, and wildlife habitats are affected. So that's the third kind of progression. If you look in some textbooks, what you'll see is, very confusingly, agricultural drought and hydrological drought can switch positions. So I'm not saying hydrological drought is worse than agricultural drought. It depends on your part of the world. Some textbooks will have hydrological drought before agricultural drought. Doesn't really matter. One is soil moisture's drying up, affecting crop growth. The other one is lakes and rivers, wetland have dried up. Carrying on from that, the fourth stage is really defining drought in terms of its impacts. So in poorer countries, in developing countries, like for instance the Sahel, when people start to die because of drought, and drought is one of the top 6 killers out of all your natural hazards, then we'd refer to that as famine drought. Alright, now famine drought is obviously a particular problem, and more of a severe problem, in your poorer, less developed countries, because people end up dying from it. Alright, the other type of drought, which has got economic, social and environmental impacts, is if we think of more developed countries, then it's more likely to affect them socio-economically. So they'd be affecting, people probably aren't going to die due to the mechanisms these countries have in place. If they've got state-funded help and things like that, people aren't necessarily going to die in countries like the USA and states like California, but it is going to affect their economy, and it's going to affect leisure and recreation and things like that. So we'd refer to that as socio-economic drought. Alright? Okie dokie. Right then, subheading: the causes of drought. Well, if I ask my mum, bless her, who's 78 years old, I said, "Mum, what causes drought?" She's going to say, not a lot of rain. And guess what? Sometimes the common sense answer in geography is good enough. So reduced rainfall results in drought, obviously, in its intensity, its amount, the fact that it might become unreliable. Other causes of drought, we looked at in key area 1 different types of precipitation, and we looked at how maritime countries with a maritime climate that are often surrounded by oceans and rely on that water vapor being collected as winds pass over the ocean and then when they reach land, that air might be forced to rise, cool, and condense, so we get relief rainfall. So that kind of links to this point, yeah. Prevailing winds, for instance, not being as strong as normal, not bringing as much moisture to the UK would be an example. The third cause is El Nino and La Nina, which can either cause flooding or drought depending on the location and whether we're in an El Nino year or a La Nina year. All right, and then we looked at relief rainfall as well. Kind of on the windward side of mountains, we tend to get 90% of the rainfall, and then on the landward side, the sheltered side, we tend to say that region's in rain shadow. All right. So if any kind of mountain ranges can prevent this wind from blowing moisture to places that need it. All right. Example would be the UK and the fact that the southeast of the UK is definitely more vulnerable to drought than the west. All right, because prevailing winds come from the west over the Atlantic, deposit most of the rainfall in mountainous regions in Wales and the Pennines, Cornwall. Right, folks, so El Nino and La Nina, it is quite a complex kind of sequence really. So what I want you to do is blank sheet of paper. You're going to draw 3 different sketches. You'll need a full page to do all 3 and label them properly. So don't be doing these kind of the size of a beer mat or taking up a full page for one. So yeah, split your page into 3/3 really, and then draw what you see on the screen. So give it a title, a normal year, and yeah, this black line represents the continent of Australasia, so Northern Australia, Philippines, and Indonesia, and this landmass represents the west coast of South America. Example such as Peru, for instance, would be a country that's affected by La Nina and El Nino. In the middle, you've got the Pacific Ocean. So just to get your bearings, if you were kind of looking at a map, then it'd look something like this. You've got Australia on the left, you've got South America on the right, and the Pacific Ocean in the middle. So we are looking north, all right? So draw that, label it up properly. Oh God, right, here we go. Right, just follow me as I go, folks. Here we go. Right then, so the first step is draw an arrow heading from east to west. And this is going to represent trade winds blowing west, all right? And these are caused by differences in atmospheric pressure. The world has got different air currents and it's part of a wider circulation system. We don't need to understand those just yet. Just think, right, there are trades blowing in this direction. We call these the trade winds. Now, what effect these have is obviously the supply of force, all right? And what it does is warm ocean water that tends to be on the surface, because warm water wants to be on the surface, cold water wants to naturally sink. So trade winds push or pin warm surface water up against the coast of Australia and Indonesia and countries like the Philippines. So you've got a mass of warm surface water just off the east coast of Australia. All right, so draw that on, get a red, looks something like this. We don't need to be Pablo Picasso, folks, it's just so you get the understanding, you can sequence it through. So that's step 2. You get a lot of warm water. And as we know, if you use a bit of logic, what happens when we've got warm water? It evaporates and it rises. Yeah. So we get evaporation. As it rises, what does it do? It cools and condenses. And guess what? We get, oops, here we go. Cools and condenses, and then we get rain, some thunderstorms, etc. Now, the key thing to remember is whenever air is rising, right, we've got low pressure at the surface. So if I'm stood just here in Australia and air is rising above my head and it's cooling and condensing and I'm getting rainfall, then that air pressure is low because it's heading upwards, all right? And whenever we get low pressure, we tend to get rain, all right? So this is in a normal year. Now, that air, obviously there's a force being applied, it's pushing warm water against the coast, it's kicking off this kind of circular system, air rises, cools and condenses. It's got to go somewhere. So to complete the loop, it has to go back, all right, to where it came from, because there's an imbalance being created. And this we can call high altitude flow. Why do we call it that? Because it's a high altitude, it's in the upper atmosphere, and it's flowing back towards South America, all right? Now, to complete the loop, air then sinks over the west coast of South America. It is important we get compass directions right here, and we're proper precise and specific. Right, so when air descends, oops. So air sinks or descends. That means the air pressure on the surface is high pressure. It's coming down onto your head, it's sinking onto the surface. So the air pressure is high pressure, and high pressure creates settled, dry conditions. So yeah, settled dry conditions, all right? Lack of rainfall. Now that's a normal year, all right? Your next sketch is going to look at what changes in an El Nino year. So your second diagram, give it a title, El Nino. Right then, so draw this again very quickly. Australia, big landmass to the west, western coast of South America to the east, Pacific Ocean in the middle, and we're going to start with a normal year. So we've got all this warm surface water pinned up against the coast of Australia, all right? And what happens is, the first step is the trade winds weaken. So the force that was pushing that warm water up against Australia is now removed, all right? So they weaken. There's been a change in kind of atmospheric circulation, all right? Trade winds weaken. That then, if you think that force is removed, what happens is that warm water starts to slosh, and that's the word scientists sometimes use, or you'll see in textbooks. It sloshes back towards South America, and its momentum means that it now collects up against the coast, or the western coast of South America. So it heads back east, all right? So just add a step 2. So warm water sloshes back towards South America. And once you've got that kind of once you've got that step, then it's just the same logic as before. Alright, what happens to that water? It evaporates, cools, condenses, and we get rainfall. So let's just draw this in. So here we go. Warm water evaporates, rises, cools, condenses, and we get thunderstorms. It's more intense, that's the key thing as well, than a normal year. So thunderstorms, rain, flooding, other hazards, because remember you've got the Andes, you've got steep slopes in countries like Peru. We've got landslides and mudslides. Yeah, more intense than a normal year. Alright, so in an El Nino year, countries like Peru are bracing themselves for even possibly hurricanes, cyclones, yeah, lots of low pressure as well. Low air pressure, forgot that bit. Silly me. Low air pressure. Alright. High altitude flow takes that air back across the Pacific towards Australia. So that's your high altitude flow, where it descends to complete the loop. Yep. So, should now be kind of making sense after you've been doing this for 10 minutes. So in an El Nino year, Australia, Philippines, Indonesia suffer from drought because air descends or sinks. This brings really settled, dry conditions because the air pressure is high. And we get drought, we get wildfires. Yep, and these can last between, 12 months, 18 months, 2 years, something like that. This cycle when it switches from a normal year to an El Nino year. Alright, so in an El Nino year, Australia, Philippines, Indonesia suffer from high air pressure, lack of rainfall, drought and wildfires, whereas the western coast of South America, like Peru, suffers from thunderstorms, hurricanes, cyclones, mudslides, landslides. Alright. Third diagram is going to look at a La Nina year. Alright, so give it a title, La Nina. Right, folks, and a La Nina year it's the same principle, it's exactly the same as a normal year, but the trade winds are much stronger. Alright, so the force that kicks these oscillations off, is the trade winds. Right, so just use some logic and kind of follow it through. So the trade winds really strong. What does that mean? It means there's even more warm water pinned up against the coast of northern Australia, Indonesia, and the Philippines. So it's super warm. What's that going to mean? It's going to mean, well, evaporation's much faster. This kind of becomes a habit when you've done it a few times. Once you've got the logic, it's really easy. The examiner thinks you're a superstar. So evaporation, really intense or rapid. Air rapidly rises, cools, and condenses. You should be doing this now without me having to say. You should know what's coming next. Intense low air pressure, thunderstorms, intense rain, typhoons or cyclones. The Australians call them willy willies, but yeah, typhoons, And Australia in a La Nina year suffers from flooding. Complete the loop, high altitude flow back towards South America. It descends and sinks to join the loop. Alright, and you've got the idea. South America is going to experience descending air or sinking air, very high air pressure, which is going to mean really dry, settled conditions. Oh, why has that moved? That's annoying. Settled conditions, and we're going to get drought. Alright then, so being able to understand this and sequence it through all starts really just with trade winds, right? If you've got the understanding of rising air, falling air, and the fact that low air pressure brings rain and high air pressure brings settled conditions and often drought, it's easy. When I'm doing this, I just remember the first step, and then I've got the confidence to be able to think it through. Yeah, if you're going to try and remember every step, you're going to be taking up valuable memory space. So, just El Nino year, trade winds weaken, and the oscillation changes. And then in a La Nina year, it's the same as a normal year. The trade wind's really strong, and it intensifies a normal year. Yeah. Best way to do that, like I say, is just remember whether the trade winds are strong or weak, and then you should be able to work it through. All right. What has this got to do with drought then? Well, if we just look at this region, if you like, this Pacific region and the Pacific Rim, obviously you can use El Nino and La Nina as a tool to explain why Australia suffers from flooding in a La Nina year, and South America, the western coast of South American countries like Peru, suffer from drought in a La Nina year. But also you can flip it and say, well, in an El Nino year, Australia suffers from drought, and it's Peru that suffers from floods. So one thing as well is on the mark scheme, folks, like I say, with compass directions, really, really precise. It's important. The eastern coast of Australia, the western coast of South America, you've got to put that in. I've seen examiners' mark schemes on the older spec kind of not give credit if you just say South America or if you just say Australia, because they are obviously continents, and you need to be precise. The way to make sure you're precise is also quote a country like Peru. And that's where Paddington Bear comes from, folks. And on that note, bring your notes into next lesson. And I might have some marmalade ready for you. I think that's Paddington's favourite snack, innit? Alright, have a good one. Ciao.